Hello everybody, my name is Mitchell Henry. I'm a application engineer over here at Concepts in Production. I'm a certified SOLIDWORKS expert and I will be presenting to y'all a webinar today on SOLIDWORKS Weldment functionality. So let's dive right in here. Here you can see under the Sketch tab that the normal sketch is a flat sketch while you can tab down and get a 3D sketch. Over under the Weldments tab itself, it starts you out in a 3D sketch. So I'm going to click it to start a 3D sketch, and here at my origin you'll see that it's got the two red arrows designating which plane we're working in. Let's start by making a rectangle, and you'll notice that those arrows expand a little bit more just for a little bit easier visibility, and you'll see here that this square that I'm making is actually on the plane created by those two lines, and like I was saying, it is the XY plane. And here I'll pivot around so you can kind of visualize what's going on. And to switch between which plane it's working on, you can hit the tab key and see here now we're working on a side plane, and then now we're working on a top plane. Alright, so there's a little bit of visualizing that functionality. Now you got to be careful with 3D sketches because you can have problems like here I'll draw this line and it looks like I'm trying to put it on our Z-axis, but you'll see by the little yellow dotted lines it's trying to tell me that that's actually diagonal, and I'll rotate here. That line is actually in the same plane as our rectangle, but from our one vantage point it did look like it was along the Z, so you got to be careful about that. So to actually get it to go in the Z, I'm going to hit tab so that I can work in the side view plane and be able to put this line over here. I'm going to go back and create another rectangle. I'm going to do it parallel to the original one. So there we got that. I'm going to connect our lines, and I'll show you another big thing with 3D sketching is that you don't get a horizontal and vertical relation. So here I'll click on this line and you'll see instead of vertical or horizontal I have along X, along Y, or along Z. Just like in a normal sketch, it is going to recommend what it thinks the proper orientation is. In this case, it is along Y. You'll see over on our coordinate system that that's the Y. So I'm going to grab that. I'm going to put a few little relations on here. I'm going to make them all along the Y, all equal. I'm going to do that for all of our four main line sets. Along X and equal. Oh, I must have messed up one of these suckers. So let's grab this one. No, let's grab this one, this one, this one, and this one. It's recommending that those should be along the X. Let's grab these ones, and it thinks that those should all be along the Z. I don't know why it's recommending incorrectly there. So here we got everything correct. I'm gonna put a few equal relations in here just so that our rectangle stays parallel and square to itself. So here we've got our rectangle set up. Now I'm going to show you all dimensioning. So here, notice that the dimension's off to the side in one plane that it's working with. So let's say that we want our box to be 5 feet tall and 4 feet wide, but I want that dimension to sit flat with the top surface. So the big thing is it's going to try to grab the plane that is more normal to the dimension. So here I can grab it there, and you'll see now because the top view is more normal than the rear view, it actually grabbed a top view for the plane that it's going to put the dimension on. So there, once again, 4 feet, and there I'm going to put that it's 3 feet. Actually, I think that I messed that up. I'll demonstrate. Once again, from the top view, and there. Now it stays flush. And you see what I mean there of they expand out to the sides in the way that I want them to. And I could change this 60 if I rotated to this and did it, then it would go out to the side here and be like it was continuing from the forefoot. Alright, so there, I'm also going to put in a few little cross braces so I can do a little bit more advanced demonstration. in a second. There, we've got our simple box. Now, here I'll emphasize, this is not solid geometry. This is not as if I did an extrude cut. This is still just sketch geometry. It's just lines. If you've got a lot of experience in the CAD industry, you'll recognize this is just a simple wireframe of what we need. So here's where the Weldments starts coming in. Under the Weldments tab, our main feature that we're going to use most of the time is this structural member tool. So I'm going to select that, and like I said a second ago, it's like the sweep tool. It's going to sweep along the lines that I select with it a cross-sectional profile of what we want. And we're going to start out with, we're going to select what standard we're working with. So here we're going to start with the default ANSI inch standard. I'm going to grab square tubing, and then I'm going to grab my size. And you'll see this top spot, it's going to grab the recently used. So if you have like 20 different sizes, you can always grab the most recently used. I think it stores 3 or 5 up there, but we're going to grab this 3-inch square profile for the start. So here, groups is the important part of this. You don't want to use multiple structural member features. You want to use multiple groups in the same feature. And groups can either be the same planar, or within the same plane, or it can be anything that's any lines that are going to be parallel. But I can't do coplanar and parallel, so I can't select that line even though I'm trying. To do that, I'm going to have to come in and do a new group. So here on our second group, we're going to go in and put these parallel lines. Our third group, we're going to grab these parallel lines. And then our fourth group, these two diagonals are not an orthogonal, but they are parallel to each other, so we can select them together. But you'll notice some of our profiles came in a little off-angled. So first off, let's fix our group 5 here. That is definitely twisted at an angle we don't want. To do that, we're going to align it. We're going to grab just any one of these, any one of the other lines, and you can actually do an offset angle if you need to twist it some. But here I'm just saying that that's a horizontal or vertical axis relative to the profile that it's grabbing. And you'll see that it has squared it up against the bottom line. And let's hit OK. See, our box looks all okay. Let's go back into the feature and I'll show you the other few little things. So maybe you're trying to set this up for one of the guys in the shop to actually produce this. Well, he's probably going to ask you to put weld gaps on everything so that there's a little bit of a tolerance. So you'll see right now there's no gap between each of the tubes. But SOLIDWORKS Weldements will put that in automatically for us. So that's what this first little sucker here is. I'm just going to tell it that we're going to have a 50 thousandths weld gap on that group. It is group specific. Anything below the group selection is group specific. So we're going to have to go in and put it in on the next one, and then on the next one. And then now we can look in here, and we've actually got a small little weld gap here, so that there is a little bit of room for the welder to get in there and kind of shimmy the part in and fill in with his welding material. But here I'm going to reset these all back to 0, just for the sake of this demonstration. Another thing that you might want to do is corner treatment. The big advantage of doing multiple groups of weldments instead of multiple structural member features is that as long as it's the same multiple grouping, SOLIDWORKS will auto-recognize any corners where multiple tubes meet together. And here it'll actually put a little purple dot. You'll see each of my corners have this purple dot. But let me click on the purple dot and you'll see it pops up this corner treatment screen, and each tube coming into the corner, and it even has the tube order. So building up our tubes, you want to set up the group, which lines you selected first for the first group and the second for the second group, to try to build up each corner. But if you mess that up, you can actually come in each one here, and maybe this yellow tube should be the second one to come into this turn, into this corner. So now this vertical tube is the primary tube on this corner, and the other two come in secondary. Or maybe we want a mitered edge, so these two both come in together. And to do that, we're just going to do a setting both of them at the same trim order level. Or maybe we even want a triple miter, so I can put all three of them come in at the same time. And you can see here, each one is triple mitered against itself, or its two neighbors. But here we're just going to go for the simple, what I had by default. And if you want a specific corner to have a little more weld gap, you can do each item gets its own specific weld gap specific to that corner. You can click here and type one in. I'm not going to do that for the sake of this demonstration. But here we've got our simple tube frame made up pretty quick and easy. You'll notice that there is one little problem here if it does not extrude all the way to the end. That's because right now the cross-section profile of our tube is extruded along the length of the tube, but on this tube it extends more out, or in this sense this one extends more vertical than the corner does. So you could, and it does this by the point along the cross-section profile that it does grab is the origin by default, but we could locate it to a different one of the points in the cross-section profile. But what this ends up with is sometimes you don't get the corners to extend all the way out. Well, SOLIDWORKS will fix that real quick for us. So I'm going to do a basic extend and trim feature. This is the other primary feature that you'll be using with Weldments. And here I'll just select the 4 tubes that I need to extend. I'll tell it that it needs to extend up to a face, and I will tell that it needs to go up to this face. And you'll see that it auto-recognizes up there, and it's doing this for each of the corners. I can do it over on this end, and there we've just done 8 quick little fixes with one simple command. So there we've got our structure set up pretty well. I'm going to hide our sketch because we're no longer needing to visualize that. Then I'm also going to do one quick other little thing of what if you don't see the tube profile that you wanted out of this list here. Maybe it's the wrong size, or maybe it's the wrong standard. Well, you can actually put in your own cross-section profiles, and let's demonstrate that now. So here I've opened up a new sketch, a new part file, and we're going to create our new geometry of the cross-section profile in a sketch. So here I'll just put a front plane sketch, and we're going to do another square tube. So let's grab a square. Now remember, I said that it defaults to the point that it drags along the line, the wireframe line, as the origin. So if we put a square like this, it's going to drag the corner. But in most senses, you're going to want the default to be the center line of the tube. So instead we're going to use this square tool so that it always puts the center at the origin. Here I'm also going to say that these two lines are equal to each other so that it squares up. Then I'm also going to say that maybe in this case we didn't like the 2-inch, we didn't like the 3-inch, but we needed a 2.5-inch. So there we've got that. Let's round the corners like it would be in the real world. It's popping up a message basically saying, hey, you're referencing lengths off of these corners, but you're trimming the corner to put a fillet on. So it has to create a virtual sharp. And a virtual sharp is here. You see that it imagines where the lines still extend to each other and intersect. And this dimension needs that virtual sharp to be able to tell what it's referencing. But that little message is not breaking anything when it pops up. So the last little thing we're going to do is we're just going to do an offset entity, and you'll see that it's creating the entire profile extended outward, but we need to extend it inward, so I'm going to reverse that direction. Then I'm also going to change our wall thickness, which is our offset distance. So here let's go with 0.05, so 5 thousandths wall thickness. And you'll see, oh, I think that it flip-flopped on me. Let me undo that. Yeah, it did flip-flop on me. Alright, so there, and we're going to reverse the direction to the inside. So there we've got our 2.5 by 2.5 outer length tube with a 50 thousandths outside diameter. So we've created our cross-section profile. That's the first big step of creating your own profiles. We've designed the profile. Second step we're going to need to do, we're going to need to design where we put this profile. So here in my documents, I'm going to create a Weldments folder. This is going to be our top level folder where we're going to point SOLIDWORKS to look for weldment profiles. But if you remember correctly, when we were using the structural member tool, the next thing that it asked for was the standards. So under the top level folder, you're going to need to create a new folder and create a standards folder. Here I'm just going to call it my standards. Then what was next? Well, the next level down was what type of tube. So here we're going to say we're still using a square tube. Then it's at this folder level that we're going to save our profiles. So we need a 3 folder level deep folder structure. We need a top level, a standards level, a tube type level, and then at this 4th level down is where we're going to save our file. So that was step 2 of setting up our own profiles. Step 3 is here. We're going to save this sketch as a SOLIDWORKS library feature, and that's a library feature is any sort of feature that SOLIDWORKS uses to create geometry. So some of the toolbox items or features, or in this case a Weldments profile feature, maybe some of the routing or tubing and such, sheet metal, they've all got little SOLIDWORKS library features assigned behind the scene working with them. So here the big step is we need to make sure that we are not working and editing the sketch. We need to step out of the sketch, so make sure that you exit the sketch. Then we're going to click on once on the sketch that we want, and so that we're selecting it, and you'll see that it turns blue here, saying that highlighted in blue, so that I'm selecting that. Also, the geometry of the sketch entities will be highlighted blue. And while that is selected, we're going to go up to File and Save As, and we're going to change our file type to the library feature part, which is just below a regular part. Then, while we're saving it as a library feature part, we're going to go to our folder structure, and then we're going to go into our top level, into our standards, into our square, and then we're going to put it at this level. So here I'm going to call this 2.5 by 2.5 by 50 thousandths. And I will note, you cannot use symbols such as the multiplication, division, minus, or plus sign here. So I'm having to use an X sign. That's notation that SOLIDWORKS uses by default. I recommend using that. It does not care about the periods though, so you're good to use those. So here I'm going to save it as a library feature part at our 4th level down. Now if you've done this successfully, you'll notice 2 things. One, our sketch over here in the feature tree, it actually has a little L next to it in the sketch picture. And up at the top level of our part, we've got little books here saying that this is being referenced as a library feature in some form or another. So now that we've got our profile saved out, that's our 3rd step. Now we're going to go do our 4th step of being able to use our own profiles. So here on our part, we're going to go to the options, which is a quick button up at the top. If you don't have it as a quick button at the top, we can go to Tools, Options at the bottom here, and then go to File Locations page. And here there's a drop down of any file referencing that SOLIDWORKS will do. And we're going to scroll down and grab the Weldments Profiles tab. So here, this is the top level location for the default weldment profiles that SOLIDWORKS uses. So we're just going to click to add our own, and here we're going to grab Documents, and we're going to select the top level. We do not want to select the standards level or the square tube level. We need to select the top level. And to be sure of that, you need to be in the folder level above your top level. So here I'm going to be at the documents level and select Weldments as my top level, then select that. I'm selecting that folder. Then I'm going to hit OK, and it's going to ask me to confirm that I want to add that, and I'm going to say yes. So here now we should be able to go over and edit our feature, and now under our standards folder it's pointing it at our Weldments top level folder that we created. So now it's going to search for standards in any of the folder structures that it does indeed see. So it does now see our My Standards folder. Underneath that, it does now also see our square tube, which is in the My Standards, and it sees our profile that we created. And it's going to apply it to all of them for us. So here we see that it auto updates. One thing that is nifty with SOLIDWORKS that they added in 2016 is you have the ability to transfer over material. So I had a material applied to our profile. So here I had it set that this was 1020 steel, and because of that, when I saved it out, I was able to auto apply the material for this part to be 1020 steel. Now, because of our slight change, we do need to update this trim extend feature to the new faces created by the new features. I can real quick show y'all, there's a few other quick, easy tools for Weldments. Say you need to put end caps in your part, it's pretty easy. You just use the end cap tool from the Weldments tab and select the face that you're referencing off of, that you're capping, and you can set it to be offset on the end, inset, and it will trim the Weldments tube for us, or inset and within the tube. Another cool feature that SOLIDWORKS Weldments will do for us is easily setting up gussets for us. So I'm going to select those two. I can set that I want a 4-inch gusset, and then it'll quickly create that geometry for me. And I can set it inside, outside, or in the middle. One more really cool feature that's really useful is that SOLIDWORKS will actually create a cut list item set for you. So each similar set of tubes, or each tube group essentially, is going to be grouped together, and it'll even create a cut list table for us of all the information that we want from it. But right now this is a part file. Maybe we want each of these tubes to be a part file, and they're all constructed together in an assembly file. Well, we can do that. We can right click on the cut list tab and hit save bodies. Auto assign names is going to grab each of the tubes and save each one individually, or I could go through and start clicking on each one individually if I didn't want to save all of them at once. Then I could hit browse under the create assembly and put a file name and a file location for the assembly that it's going to create. Maybe you don't want it to be an assembly though, and you just don't use this create assembly level, and it will just save out each of these files. And that's real nifty if you need to send over, like this diagonal tube has some corner treatment on it, so saving bodies allows you to send over to your CNC guy, or maybe make a detailed view of what the corner treatment or corner profiling is for that tube. So one last thing that I'm going to show y'all is how easy Weldments is to work with drawings. So we've created our box. Well, now we got to make our drawing for our box. So I'm going to open up a drawing. I'm going to quickly and easily just drag in our front view. I'm going to put our top, side, and isometric. I don't like the sizing of it. It's a little too large by default, so I'm going to go to properties and change it to a slightly better aspect ratio. I like that. That's pretty good. So here, we're going to go under the annotations tab. We're going to go to tables, insert Weldments cut list. I'm going to select that we're grabbing the cut list from there. I'm going to hit OK, and see here, it's auto going to put in the 4 different tube types, the quantity for it, the material, because I've set that, and the length of each individual tube. We've also got assigned which tube is what, referencing this table, so we can just hit the auto balloon button up here, and it will automatically create balloons for each of our different cut list items. Alright everybody, well, thank you very much for coming to join in. I hope that y'all all learned a lot about SOLIDWORKS Weldment functionality.